So our path is all about doing version management of software artifacts. If you look at what we have, we built a centralized version repository. You should think about this as your software distribution hub. Every piece of software that belongs to your business gets deposited in the version repository. That might be an operating system component, such as Red Hat or Windows. It could also be a piece of middleware, maybe Oracle or BEA. In the end, you have your internal application developers who are also depositing things into this repository. You put everything into one repository, one central location for a couple of reasons. First of all, it gives you control. You know every piece of software that gets deployed onto a piece of infrastructure in your business. You can go onto a machine in your business and you can take a look and say, what's here? Where did it come from? What's the provenance of this software? How can you trace it back from a deployed artifact all the way through to where it came from? You can also put rules for that piece of software in the repository, saying this piece of software needs these 10 other things or it won't work properly. You have a way of encoding that, and you have a system for understanding that. What this really gives you is a way of modeling your infrastructure by having all of your software in a single repository, a single location. Now that location is virtual, it can spread, it can scale, but it's a logical place where all of your system administrators, all of your developers, and all of your patch and release management architects can work together to understand what kind of software you're deploying. You can take these software artifacts and you can deploy them onto bare metal, onto machines, into virtual environments, or into cloud environments. When you do a deployment, that deployment becomes version controlled. What's that mean? Well, it means that when you go to a machine, you have to, every machine, every installation has a single version number. The idea of a single version number is actually really important, because how can you log into 1,000 machines and know whether those 1,000 machines are running the same thing? In traditional worlds, you might have 1,000 different version numbers, 1,000 different RPM version numbers of DLLs or of the .NET framework. How do you understand all those version numbers? Those lists get very long. What your sysadmins need to do their job is to be able to look at a machine and say, I understand that this machine is running this software of this version. Underneath that version might collapse down to 10,000 version numbers. It really doesn't matter. But when you go buy a car, you buy a 1995 Buick. You don't buy a Buick that has this kind of engine and this kind of tire and this kind of oil. You want one number, one version number to tie it all together so you can understand what it is you have. Other advantages of versioning are for change management. After all, what is a change? A change is moving from state 1 to state 2. As things change in your business, you're applying changes to machines. You're moving from where it was to where it will be. The easiest way to describe that is by capturing all of the states in between. If you understand all the states of your infrastructure, you can start to understand change. There's no other way to understand change. How can you inspect change? How can you say, what is changing in these machines? How can you capture change so that when something breaks, you can say, well, what was it like a week ago? What change happened from where I was to where I am that caused my performance to degrade, that caused my stability to go away, that caused my memory usage to increase? You want a system where you can report on change, and you want a system where you can roll back change, where you can undo things. By capturing all of the states, all of your software artifacts and version control, you can do all these things. After all, state 1 and state 2, 1 and 2 are just version numbers. By representing those version numbers, by representing those states inside of a version repository explicitly, you can have change. Change might mean patching. It might mean updates to an application. It might mean a rollback. Those are all capabilities you get from a version repository that it's very hard to do in a controlled way without a version repository. The final thing that you can do with this that's really important is audit. So across all of this, you can audit your systems. What's audit mean? It means comparing a system to what it's supposed to be. There's lots of solutions out there to say, compare me to what you were yesterday. Intrusion detection systems do that. That's only useful if you know what it was supposed to be yesterday and you know that it's supposed to be like today. If a change came in, was that change supposed to be there, or was that a change that was uncontrolled? Was it a hacker going in and replacing something, or was it something that a sysadmin did to fix a problem in the middle of the night? So an audit system tied to version control can look at the system, inspect what's on the system, and compare that to a definition of what's supposed to be on the system. And by having that auditing, you get things like compliance, whether compliance means PCI, whether it means SARbox, whether it means any of these other standards out there for compliance. it gives you the ability to measure a machine against a compliance goal, to measure a machine against a known state. So if you can measure a machine, you can move a machine, and you can describe a machine, you have a very powerful solution for controlling all of your software distribution within an organization using a software distribution hub like the RPath version repository.